Hi, I'm Suzy Chairman and I'm the Executive Director of the Road Safety Foundation, a charity established in the 1980s. You might know us from our annual crash risk mapping work or from our involvement in the Safer Roads Fund. We work closely with our sister charity IRAP, working primarily on safer road infrastructure, but you might also know about us from our work running the Older Drivers Task Force. Today, I'm going to talk about IRAP and safe speeds. At the centre of the safe system is the road user that requires protection from crash forces that can overcome the human body. A safe system is one where we have designed out the possibility of crashes resulting in a fatal or serious injury. So for a safe system, we know that we need to align the speed of travel with the provision of infrastructure and traffic mix present. The graph on the left is from a PhD thesis by Ramborg in 2005, where they analysed in-depth crash investigation data, and it shows the impact speed along the x-axis and the fatality risk on the y-axis. Here you can see that fatality risk increases sharply with impact speeds above 20 miles an hour for pedestrians and cyclists. And this is why there's a big push towards 20 mile an hour zones at the moment, and why segregated facilities should be provided where speeds cannot be lower, i.e. when the road has a movement function. Similarly, side collisions like the ones you might get at T-junction or crossroads become much more likely to be fatal at impact speeds above 30. Head-on fatality risk increases sharply above 45. On the right is the latest meta-analysis of survivability research provided by Jess Trong and her colleagues. Here we're looking at the impact speed at which only 10% are severely injured, not fatally injured like in the Ramborg work. Severe injury is the worst of the serious injuries. So it's not all serious injuries, just the ones that are really life-changing. For car to pedestrian crashes, the impact speed at which only 10% of crashes will be severe is 15 miles an hour. For car side-to-side impacts, the impact speed is 40 miles an hour. For head-on crashes, the impact speed is 30 miles an hour. I've highlighted on their full table the speeds that I've just described in the columns on the right. They are equivalent to the speeds in the Ramborg work. Of course, you might have noticed that for the Ramborg work, the survivable speeds are higher for head-on crashes and lower for side impacts, and they're the other way around in the Trong work. Also notice that when we have power two-wheelers or motorcyclists involved and heavy vehicles involved, the survivable speeds are much, much lower, reflecting the relative vulnerability of motorcyclists and the increased vehicle masses when heavy vehicles are involved in crashes. We have a number of challenges here. High speeds are viewed as offering better mobility. When we appraise transport schemes, we take the journey time and we also take the value of the human lives in and prevention of serious injuries in terms of monetizing those. And actually what we end up doing is valuing higher speeds and lower journey times more than we value human life. In fact, we value journey time twice as much as we do human life. We're used to moving around faster than is ultimately entirely safe for everybody. And standards are based on design speeds, not survivable speeds. Upgrading roads so that they're safer at high speeds can be really quite costly. What on earth do we do when we can't afford to invest, like on bendy single track lanes where it just isn't commensurate with the level of traffic using them? And heavy vehicles and motorcyclists, is it really realistic to try and create a safe system where these road users are present? IRAP has now reached over 120 countries globally with 1.5 million kilometres of road being star rated. The star rating system reflects the relative safety performance of roads from 1 to 5. We're really happy to be part of a global programme making an impact all over the world. And some of what we do here in the UK supports other countries in taking forward their own life-saving initiatives. And here's our UK infographic. We've now star rated 32,500 kilometres of roads. That comprises the entire strategic road networks in England and Wales, and we've been helping DfT with their £147.5 million investment on local A roads as well. We've also got nearly 1,000 IRAP software users in the UK now, and 2,500 people have been trained at events. So it's worth just having a think about what the star rating system means in relationship to speed. I'm going to be bold here. All roads are safe at A speed. That speed may be below the posted speed limit in many cases, but it is possible to get the balance right between road design and character and the speed of operation of a route. The diagram here shows a rural road with clear roadsides, well, clear enough roadsides, a race profile marking, a little bit of a narrow strip for correction, and central hatching in the median. This road can operate at 5 stars right up to 40 miles an hour, at 4 stars up to 50, and 3 stars up to nearly 70 miles an hour. The design affords quite a high safe speed. Now, perhaps a more realistic single carriageway rural road. We have a slight bend, we have roadside obstacles very near the running lane, and no central hatching. This road achieves 5 stars only up to 20 miles an hour, 4 stars up to 25, 3 stars up to 30, and only 2 stars up to 40 miles an hour. Imagine this is a typical single carriageway rural road on our network that might operate up to about 50 miles an hour. And here we're scoring just 1 star. The survivability of this layout is very, very poor. And that's why the star rating is low. What can we do here? We can drop the operating speeds to 30, but that's probably going to be a bit unpopular. Instead, we might consider dropping vehicle speeds to 40 or 45 through various speed management measures, including speed limit reductions, engineering measures, possibly enforcement. But we need to go further. So you might have to engineer up the safety provision of the road by protecting roadsides and also maybe adding in a bit of narrow central hatch to reduce head-on risk. So thinking about this, it's important to frame the star rating as being a kind of measure of how well the operating speeds marry with the infrastructure provided. And thinking about this gives us vital intelligence to determine what to do for a route. And often that'll be a compromise between a bit of speed management and a bit of infrastructure treatment. When it comes to speed, we spend a lot of time talking about compliance with speed limits. However, more fundamental than this is how much travel happens across the network at a safe speed. So I'm going to introduce 3 speeds to think about. Functional speed, that's the speed at which the road needs to run at to fulfill its role within the hierarchy of roads. Safe speed, that's the speed at which you should survive crashes. And the credible speed is what feels natural and sensible to the road user. And philosophically, I would argue that the safe system is achieved when these 3 speeds are in equilibrium. Where one aspect of this fails, we have a dysfunctional system where death and serious injury will occur. Major connector roads, like roads connecting 2 towns, for example, need to operate at higher speeds than country lanes. For those more minor rural roads, you might take the view that they don't need to function at such high speeds, as their purpose is for local travel or to feed into more connected routes. And so the speed limit may be lower. Cycling and walking might be encouraged, for example. So how do you understand what a safe speed is for a road? Well, one way I would advocate, of course, is by using an IRAP assessment. The speed at which 4 or 5 stars is achieved can serve as a useful proxy to understand the safe speed for a road. You aren't, of course, going to do a full IRAP survey for all of your roads, only the more primary ones. So setting an appropriate lower national speed limit for rural single carriageway roads would seem like a good idea. And where you wish speeds to be higher, because the function requires it, you can of course assess these and post a higher speed limit by exception when you've risk assessed and understood that risk on that road, and maybe treated it as well, hopefully. Finally, the 85th percentile speed can give us an adequate idea of the credible speed, though this isn't totally pure, as it will be influenced a little bit by the posted speed limit and levels of enforcement. So what's the process? I would argue that what we need to do is define the function of a road. Understand who needs to use the road, what for, what its purpose is. Is it a distributor, a feeder, a residential street, an active travel route, or a school route? Assign a desired functional speed for the road, and look at where improvements are needed to allow safe operation of the route at the desired functional speed. What are the options for improvement, and work out whether these can be planned and prioritised according to their benefit cost ratio, because of course we don't have all of the money in the world to fix all of the problems right at the beginning, so we have to still prioritise. So it's an okay, reasonable approach, but part of credibility is about consistency, which you don't get when you address the road network bit by bit. In fact, you can end up with quite an inconsistent road network. Functional hierarchies ideally need to be defined at the national level for consistency, to allow us to take advantage of the national speed limit system and also the opportunity to communicate key changes with the public. So if we're being really serious, we might look to the Dutch Sustainable Safety Initiative for inspiration, where they have blueprints for each road type on their network. They have speed limits assigned to each that are credible and safe, and they work towards those blueprints. incrementally, and they have been at it for a couple of decades. So it's not something you do in one hit, but something you can work towards and have that common vision of where you need to end up and land if you were to achieve a safe system. So what tools have we got now to help? So this is the route review tool that you can see on the screen. And this is what we have at the moment available for local authorities and national road operators who have undertaken IRAP surveys. The line down the middle of the map is your raw star rating. So 5 stars is green, 4 stars yellow, 3 stars orange, 2 stars red, and 1 star black. And you can see as you move along the route, this changes. Top right, you've got your fatal and serious injury profile, which shows you how many fatal and serious injuries you might expect as you move along the route. So where you've got spikes in risk, that reflects in the number of fatal and serious injuries that we expect once we've multiplied out by flows. We have these fatal and serious injury profiles for all of the different road users, vehicle occupants, motorcyclists, pedestrians and cyclists, and they have different crash types that underpin them. So here for the vehicle occupants, you can see we've got property access, fatal and serious injuries, got head-on overtaking, run-off road, loss of control passenger side and driver side, head-on loss of control and intersection types of crashes. And we can see as we move along what kind of fatal and serious injuries we might expect. But paired with this, we also have the speed profile. So this shows the posted speed limit in blue, which is kind of hidden underneath the green line a little bit as you move along. And the green line is the mean speed and the red line is the 85th percentile speed. You can see that these change every 100 meters or so because we're using telematics speed data, not spot speed surveys, in order to obtain this information. It's a really rich idea of how the road is performing when you pair both the fatal and serious injury profile and the speed profile together, where you can see spikes in the fatal and serious injury profile. You know that these speeds are not appropriate for the road design as it stands. We also have the recommended countermeasures, both in the bottom left window and the bottom right window at the 100-meter level. What the modelers recommended as being a viable and sensible treatment that has a good benefit cost ratio. And you can turn these on and off in the route review tool to create your own user-defined investment plan, which you can then run back through the model, process it, and it will tell you what the impact is on star ratings for each of the road user groups, but also importantly, the impact on fatal and serious injury that we expect. That we can monetize and put into proposals and business cases for investment. You can also see a picture of the road as well as you go along, which is great. So you can move back and forth and select and deselect your countermeasures as you go that you want to apply. So what's coming soon in the route review tool, probably sort of March, April time, is the addition of those other speeds I spoke about. So the functional speed, I've just mocked this up really quickly, so apologies for how rough it is, but the black line is your functional speed. So the speed at which the road should be able to function. You've got your mean speed and your 85th percentile speed still, and your posted speed limit as well, just as before. And then in the background, we'll be displaying the speed at which you achieve the different star ratings. So speed at which you achieve 5 stars, I've just sort of put some green markers in the back. So within this, this sort of area of speed, you can achieve 5 stars. So at this particular location at number 2 chainage, you can see you can achieve 5 stars up to 40 kilometers an hour, for example. Then you've got your 4-star speeds, your 3-star speeds, and there'd be 2 stars and 1 stars above, but I couldn't work that out very easily with all of the wiggly lines. So what we'll be able to do is look along this profile and see where you've got those mismatches between the safe speed and the functional speed and the operating speeds, and spot where you can make a difference. You'll also be able to look at this at the multiple road level and the network level. So you'll be able to display all of these speeds, functional, safe, 85th, and so on, and posted speed limit. But you'll also be able to see the differences between them, where you've got the greatest disparity between the driven speeds and the safe speed, for example. That's your safety gap, your posted speed limit and your safe speed, and so on. And then what you'll be able to do also is to apply speed management countermeasures to the routes and so on to test them out. So you'll be able to apply a speed limit reduction of 10 miles an hour, and that'll tell you what the impact on star rating and fatal and serious injury is likely to be. You can then test out things like a 10 miles an hour speed limit reduction plus average speed cameras, or introducing a vehicle activated sign or whatever that thing might be that has an impact on speed. So that's going to be a really big advancement, because the IRAP methodology is focused very much on building and building safer roadsides and increasing the safety provision of the road. But actually, sometimes we need to do a little bit of both speed management and building up the safety provision. So this is what that will allow. So are we ready for a rethink? How do we view mobility? Is faster better? Do we realise how unsafe current speeds are for the road environments that we have? Can we invest in defining the functional hierarchy of our roads afresh, and can we reach agreement on this? Can we invest in safer provision on roads that need to have traffic moving relatively fast? So we invest where we want fast movement, but we also then manage speeds down where we don't need it. So we don't need to invest. Can we invest in better facilities for vulnerable road users, particularly where speeds are above 20 miles an hour? And are we prepared to lower speed limits, even national ones, for roads that do not have a city-to-city or town-to-town function? So starting off with a low national default speed limit for rural roads, and then exceptionally up where we can actually do that risk assessment